Hey everyone, welcome back to one of our episodes here. We're starting to do these bit of a rundown of some factory issues and so forth. And this is Jasper Martinov. He's 2IC engineer here, helping us out with all the drafting and ideas and design process. So I just want to let you guys in. My name's Jared, of course. This is sort of how we brainstorm. We do like to get factory parts. Compare from there. We do buy a few broken cars as well, like from the auctions, and so we see accidents, what break, because it's always good information to see what actually breaks, where it breaks, and then discuss from there. Is it worthwhile reinforcing, making something better, modifying slightly, or reinventing the whole wheel as such? So here we've got the factory knuckle, the original one that's been selling since 2020, and the BG50, the D-Max and the MUX in 21 I think it was. And then we've got the two outer ones here, which are actually the new revised ones. So I'll let Jasper run through a bit of information with these and what Isuzu said about it and what we've measured up, because we wanted to make sure that we saw what Isuzu did and test that theory and go from there.
Obviously, we know many people have heard of the bump steer problems that Isuzu have in the latest chassis from 2020 onwards, and they released these new knuckles as a replacement. For certain people who meet certain criteria, they'll swap out your old knuckles to fix the bump steer. And we thought, all right, we'll see what they've actually done, and we've got our own measurements. We know where they stuffed up from the beginning. I don't know when it was, maybe 21. We had a chassis in, and I remember we went to roll it off a trailer, and because there was no engine in it, the front of the chassis came up, the suspension obviously compressed. It wouldn't move off, wouldn't roll downwards off a trailer. There was so much tow in it, so we straight away saw there was an issue with the bump steer. Also putting them up on the hoist and that, you could see all that.
Well, knowing it was a driving car before that and all the weight taken off, it should have been rolling. It wasn't an accident, it was a flood.
That's right.
It was a flood victim. It had about 5,000 k's, a little bit over that, so really no sign of wear or anything like that at that point in that car.
And that was when we first came across, I guess we really saw that it was a big issue. And then from there we went and started measuring things, and we found that the steering rack was mounted 16 millimeters higher at the chassis than where it's mounted here at the knuckle. So basically, where your, I guess it's rack end, where it's mounted at the chassis, the rack end to the lower controller mount on the chassis was 60 mil higher than your lower controller mount on the knuckle and the tie rod end mount on the knuckle. So that difference creates the bump steer. Every single car, up until they've changed the knuckle, has the exact same geometry. They've all got the bump steer, they've all got the same problem. The only difference is driving styles and suspension setups. Now, if you've got a stiffer front end, you're not going to compress your suspension, you're not going to have suspension travel, and what occurs with bump steer, as the suspension is going up and down, your toe is changing in and out. So if your suspension does not go up and down, your toe does not change, you don't have tyre wear. Now obviously that's impossible, you're going around roads and whatnot, but some people have got really stiff front suspension and no problems. Some people drive very gently and don't heave on the brakes or nail it off lights, and the car doesn't move, the front suspension doesn't move so much, so they also don't have problems. Then a lot of people do, and it's not they're driving erratically or the car's set up wrong, it's that this is designed wrong. You should have at least a much closer, with the mounts, they should be a lot closer at the chassis and the knuckle than what Isuzu have done. So
more parallel, basically.
And you can see that in the tie rod / rack end compared to the lower control arm. The angle is obviously much steeper from factory, where Jared said they should be parallel. So the gist of it, we found 16 mil was the difference. What have we got here? Well, this is your, like you said, early knuckle, and this is the later knuckle, and we can see there is a difference. Isuzu have moved it up to correct it. We fixed it at the rack. So on the chassis, we dropped the rack down, which is a cheaper way of doing it. You don't have to touch this giant piece of steel. So we dropped the rack down to correct it. Our offset rack drops it down 8 mil with the offset bushes, and then the weld-in rack relocation drops it down 60 mil. So what Isuzu have dropped it, or raised it, sorry, is 12 mil. So they've gone up 12 mil, and we'll come in with the camera and show a few reasons why they've only gone so far. But one other reason that we can think of is they do want to keep a little bit of the bump steer for when the vehicle is laden. So when you put load in the back, the front suspension is going to obviously come up, and you're going to gain a little bit of positive tow with that, with how they've set it up. The advantage of that is when the weight comes off the front, with that extra toe, you're still going to have good steering feel. It's not going to become wavy. The vehicle is still, you're still going to feel in control of the vehicle.
We're only talking a very little bit.
Yes.
Like we're not talking 7 degrees, what it was for the factory, or give or take was 7 degrees, wasn't a toe of overall travel. So we're really looking down to 1 degree, probably not even 1 degree.
And so this is we can see now here they've moved it up 12 mil. So it's just a little bit more than our offset rack drops, but a little bit less than our welding kit. With that welding kit, we've basically got the bump steer down to, I think it was
0.7 or 0.8 degrees.
Yeah.
8 inches of travel. So that's overall suspension movement.
It was about a 90%, around 90% reduction in bump steer. We don't know about the Super Pro knuckles, we haven't checked them, but we would assume it's around the same 60 mil
If they've
drop.
done the homework right, they should have worked that out as well.
Yeah, it should be around the same 60 mil drop. So Isuzu have not gone as far. And part of the reason, like we said, with suspension design, the other part of the reason is the interference with the ABS sensor and how they've done this. So Isuzu have said that they've made this improved knuckle more robust. Not that they've changed the geometry of anything, but just more robust was their wording. And they're not entirely wrong. We can see here around the ABS mount, it's definitely a lot more thicker. They've brought it down a bit here compared to the version 1, the early one. But you can see the main difference is here around the tie rod pickup point. So there's a lump down here, and on this one you can see it's nice and flat. That pickup point has been lifted, and obviously that's the original part here, and that's been brought up. And then they've brought this part down, this real bulky part here, where the ABS sensor goes. They've continued it down. As you can see here, it doesn't have it, but they've continued it down here. Just to give it a bit more strength there. We have had a car in which was in a huge impact, and this was broken off through here. So this will obviously increase its strength a bit. You've also got a very tight, sharp radius here, so bulking it up is always a good thing. And yeah, that's the I guess robustness that they're talking about. Apart from that, the knuckle is basically identical through here. The only differences are your casting points, casting marks, but that's got nothing to do with the strength of the knuckle. The real change is, as we can see the difference here, there's actually a 12 mil difference from original to the new. That's what they've done to help correct that bump steer.
So those little bits there definitely make a big difference when you're looking at the strength of steel, but also the shape of it. They've kept everything really nice. The machining's beautiful on these. It's one of those things where like we don't want to say Isuzu's done a bad job. They sort of did, but they've also come to the bar of fixing up that issue. They come out with a nice part. Big advantage of this, it's about the same price as I think as the knuckles that you get from the other company, but when you're looking at something like this, it's a factory replacement. So it's actually made by the factory. You don't need post-engineering once fitted, where the other ones you do. I don't know what LS codes, I can't remember the code.
I think LS3 and LS4.
Yeah, so because it's a structural member, you do need to have that fitted, then engineered post-fitment.
So talking about that, why? Because can't the company just engineer it and say it's good to go? Well, no. The problem is I can design a knuckle which will work with my, let's say, negative 22 with 22 offset tyres, but now a bloke comes and puts it on his car where he's got, say, positive 22 and it's hitting. The whole point of engineering and mod plating that is to make sure that the part works on the vehicle that it's fitted to. Post-fitment, you need to get it checked over by an engineer / signatory. They'll sign off on it and say, yep, you don't have any CV binding, suspension components touching or rubbing, all that sort of stuff, which falls under the National Code of Practice for Light Vehicles, NCOP V4, I believe they call it. All those things need to be considered, and then the engineer will give you a mod plate to say, yep, your thing's legal. Because this is a replacement part, from the manufacturer, from Isuzu, it's not a modified part, but a replacement part, technically speaking at least. There's no engineering requirements. You're simply unbolting your original part for another original part. It's all good. Any other aftermarket company, it's just the way that it has to go because they're not the factory manufacturer for these parts.
Yeah, so the factory, obviously, Isuzu do a lot of testing, and then a company like us, even when we do our stuff, we do destructive testing as well as FDA testing, whatever we can do, but we always make sure that it's like when Isuzu redesign something or when they've designed it to start off with, it needs to fit a standard vehicle as well. So the standard vehicle is the, what is it, positive 30 something offset. And if then we know some people go straight up away, you know, to a tyre size, straight up, one size up, down to a 32. So you got a wider tyre. Basically, then if you've got that very inset wheel like rim, then you put a bulkier tyre on. You've got then issues with the tyre rubbing. We've actually had a car come in just the other day. He was actually rubbing on the internal components, which he didn't realise. But that's where the engineering has to be checked as well.
Yeah,
it's a contacted part, binding, scrubbing, whichever you want to call it. That would in turn rub the sidewall, rupture the tyre.
Yeah.
That could cause an incident where people are hurt. So it's very important to have that done, just to make sure that, as Jasper said, everything fits on that vehicle particularly.
Talking about, while we're on the topic of engineering, same thing goes for upper control arms that are not factory. The simple truth is, it might work on one person's setup, one person's vehicle, the next guy, he's got a different setup, they don't work. Something will contact, something will rub. That's why they need engineering post-fitment. There was an example of an adjustable upper control arm recently, where the company that fit the upper control arm adjusted it wrong. It was way out, but the guy's tyre was hitting the upper control arm. That's a no-go in terms of legality. And even though that those arms, when they're adjusted correctly, they don't have problems. In this case, in this scenario, that would not pass engineering because it's rubbing. So that's why post-fitment is required for upper control arms, for knuckles, for all of this stuff. It's all there in the National Code of Practice for light vehicles. It's written down.
One of the things that we didn't mention as well, we mentioned it quite a bit, but in this talk here, it was to get a scope of everything. By adjusting that rack, you're actually adjusting the rack angle at full droop as well, because we know that people are bending rack ends. You can make it as strong as you like, it's still bending because you're locking out that ball joint.
That's right.
So either by what we do with moving the rack down or this position moving up, you're essentially leveling that angle more to the control arm itself, which is actually reducing the angle at full droop and wherever the car's sitting at the time. But things bend when it's at full droop because they're locking out.
No more travel.
Yeah, that's it. That comes down to engineering again, up control arms, struts, all that sort of stuff. If the struts are too long, it overextends things. Then, first thing people do is cut or bend those droop stops out. Yep. So that gives that more lift and
more comfortable ride, because it's no longer tapping on your upper control arm. But that's obviously more issues.
Yeah, with the poor little ball joint there, you can't actually feel that binding up because it's only a little ball joint. People look at the tops and like mainly the top ball joint because they can see them. It's a big one. It does. You can actually feel it in the car where that little knuckle there, you won't feel that at all.
Until it goes bang and that wheel's,
And then you complain about, the arms are weak, the rack ends are weak, how do we get a strong one? It's not the case. You've got to find the root cause of it. So the root cause is too much droop or incorrect camber adjustments and all that sort of stuff, which obviously if you've got excessive camber, that means there's more angle on everything as well. So it is exactly how you set that vehicle up. So basically, just to conclude on things, a lot of you are wanting to know about, is the knuckle a fix? We feel yes. Yes, they've done a great job with this. Basically, there's been an issue from the start, we know this. It's taken a while to come to the part with these ones, but they have come to the part, which is good. We're not here to diss the company in any way. I've got Isuzus. I've always had them since I think my second car after I had a Mini, but most of the workers here have got Isuzus as well, or Holdens, the Colorado, same thing, Mazdas. It's a simple fix. Yeah, in all, we're happy with what they've done. They've done a great job. We probably run it on the MUX, won't run it in this because we've got the welding kit. But as you can probably see, there's a lot of new stuff in here. We'll touch base on the build for the D-Max, the space cab, the big rig. A lot of blue. Got other companies doing blue as well, working with them to get things set up nicely. So the main thing we want to get is everyone happy with the car. You put a car, spend a lot of money on it, you spend a lot of money modifying it, we want you all to be happy. Isuzu want you to be happy too, so is Mazda, everyone's wanting everyone to be happy, so let's all work together. Any questions, just ask us. You can give us a call, message, whichever you want to do, email if you need to. But Monji Mods is open too, so if you want any installs, we can supply all sorts of things now, working with a lot of other companies to bring their parts in to get it all fit up for your car. So give us a yell, tell us what you think. Thank you.